Hey everyone, my name is Nyah Macklin and welcome to Effective Context Engineering Techniques for Artificial Intelligence. Let's dive right in. So again, my name is Nyah and I'm a senior software engineer and a developer advocate here at AI4J. So my research often focuses on graph theory, graph algorithms, and context engineering as well, right? But I also like to make sure that we're understanding the architectures that are best suited for these black box scenarios when it comes to artificial intelligence, and so that we're able to decipher and able to trace and explain exactly how artificial intelligence actually works. It's also a part of my core philosophy to think critically about the very technologies that we're trying to adopt, right? And that I try to promote and therefore center ethics in this conversation. Ethics, governance, safety, and responsibility, especially when we're having conversations about artificial intelligence. So I'd like to mention before I get started that in a previous life, I was actually a teacher. So you'll see lots of different memes and visuals here today, and that specifically is to make sure that you are gathering and garnering some imagery around the conversations that we're having to try and solidify the concepts that we're going to talk about today. So I like to think that imagery is better for possibly visual learners, so that those who learn best with just a conversation, but also I want to make sure that we're learning best for folk who have different learning capabilities. So let's actually dive right in today. So let's actually start off with a question. What happens when dozens of AI agents have to work together? So in reality, if you simply unleash a number of different AI agents together, then there could be some chaos, right? There can be some chaos. There's a large risk that you're actually going to get something that looks something like this. Okay, so here, this is a picture. It's like you are clear to do whatever. This is a picture of lots of different airplanes that are flying and doing really whatever they want to, right? And we have air traffic control saying, do whatever you want. Land the plane, don't land the plane. It's really not our problem. You can figure it out, pilots. But I like to say that when you have dozens of AI agents working together, it's like planes that are deciding where they should land and what they should do without having air traffic control actually in place and doing the work. So the same actually goes for agents, right? When they work in swarms without structure and without orchestration, it actually seems like madness. But when teams are putting agents into production, oftentimes, just like we see here, 95% of AI pilots or projects are actually failing, right? And that's according to the study done by MIT. And that's ridiculous, right? When we're trying to create an agent and then we create an agent and we scale that agent, you're going to have several different agents that are trying to work together. So if that entire project is failing, that's a lot of time and a lot of money that's invested, right? So let's freeze here. Let's freeze. Why are these AI agents failing? And AI projects are failing mostly because they don't have context. So they're flying around in swarms without that air traffic control, which knows which plane is landing at what time. And it knows that this other plane has an emergency and it needs to land here now. It knows that this particular gate, if we're going off of that plane analogy, this particular gate is closed and we need to have this other plane be on standby, right? All of this is important for your agents to know, right? Agents now don't have a common knowledge that ties them all together, and so that they can work harmoniously. And this is the missing ingredient. They're missing context. So, context engineering. Context engineering, how I like to describe it, is a discipline that systematically provides models with the relevant information, tools, and instructions that any AI agent would need in the correct format and at the right time. So it's trying to accomplish a particular task with all of that information in it. So unlike prompt engineering, where you're trying to get some different words, a combination of different words in order to make your LLM work in the way that you want it to work, context engineering actually centers on building dynamic systems to assemble complete and structured context for each LLM invocation. And that shift in focus from cleverly worded prompts to comprehensive contextual design is why context engineering is now considered a critical skill for AI engineers. And there's so many different ways to do context engineering. So if we see here, right, there's several different techniques that practitioners can use to improve the contextual relevance of your agentic development. So those different techniques are including RAG plus hybrid search that we see here in the corner, memory management that we have represented by this very friendly and forgetful fish, Dory. I'll get into that story a little bit later. We also have structuring and ordering context, order in the court. And then lastly, we have tools and function calling. Not lastly, but second to lastly, we have tools and function calling as another method for context engineering. And lastly, we have knowledge graph augmented context, which I like to represent as the Sherlock Holmes of context engineering. So let's dive into each one. So the classic approach, the one that most of us here are developing on, what I would call naive RAG. Right? So naive RAG often uses vector databases of embedded documents and performs semantic similarity search to find texts that are related to a specific query, right? So however, what I'd like to say as well is that pure vector search can retrieve off-target information, resulting in context poisoning, which then can lead to the wrong answers or the hallucinations that AI agents often give us. And we try to combat this most of the time with RAG plus hybrid search. So we combine vector semantics with symbolic filters, for example, either keyword or metadata filters to ensure relevance, right? And many practitioners also use contextual chunking as a particular method, where the more hands-on approach, which involves deciding how to split and how to label chunks. And that can help you preserve meaning and improve your retrieval overall. But this all can help you get a more contextually aware embeddings. But there is actually a trade-off here. So you have to take the time to decide those splits and labels when you're doing that trade-off. And RAG, either naive RAG or even hybrid RAG, what I like to call is the OG, right? That method is the method that most people know for context engineering, but it doesn't solve all of our problems. Naive RAG doesn't solve all of our problems. So we have to turn to another method. Memory management. So memory management is another version of, or another subsidiary of context engineering, represented by Dory again. And that happens when an agent interacts in a long session or across different sessions, and it accumulates a lot of information that it needs to remember, right? So we like to use techniques such as either the sliding context window method or recency-based memory, for example, where you can drop the older, more recent context history, and the trade-off, though, there is that your agent is going to lose some important information and important details that was deemed older, right? So you can often, to combat that, you can often use like summarization of history, episodic history, for example, or like global state memory. But all in all, managing memory is deciding what gets forgotten, really. So that's why I have here Dory, who, if people know either Finding Nemo or Finding Dory, a movie way back when, but it was this very forgetful fish who you tell something to, and then 2 seconds later say, I don't know what you're talking about. Who are you? What's your name? Right? So that's how I like to represent memory management within context engineering. It's trying to decide, what am I actually going to forget? Let's keep moving. So you can also use context structuring and ordering as well. So I have here order in the court to try and make you remember ordering different information. So Anthropic, for example, has different guidelines for long prompts, right? So I'd say, for example, like placing the most relevant or critical information at the top. A lot of us do that, and sometimes it's second nature now, right? We will put the most information at the top of the prompt where we're guiding our agent to make sure that the agent really focuses on that information. And since models often pay more attention to the beginning of the context window, that is a perfect semi-solution for this issue. But remember, in this case, you always have to do that, right? And so there are some trade-offs that you'll face if you're going to go this approach. So because of those, let's actually look into another approach for context engineering. So additionally, we can use tools and function calling. So I have here represented MacGyver. For those of us who are older, know about MacGyver. He always had a little tool set that he can use to get out of any situation that he was in. So instead of stuffing your context in relationship to AI agents, instead of stuffing your context with raw data or different instructions that are necessary in order to do complex calculations, we would then offload a lot of that work into these tools. So instead of your agent doing the complex calculations themselves, you just call a tool. And really, tools and function calling is just like I mentioned, function calling. It's writing out a function, you'd call that function, it would do the thing for you instead of your agent itself having to do all of that work. Instead of giving an LLM a large table and asking a question about that specific large table, that actually would consume a lot of different tokens, right? You're just trying to stuff the context with as much information as possible. It actually might be better to give your LLM a database query tool. Right? So your LLM is going to be able to, or your agent specifically, is going to then be able to execute that query and get a summarized result to then feed into the context. But by the specific use of tools, we keep the agent's focus on the thing that agents are really good at, which is reasoning, right? While offloading all of the heavy lifting onto this tool. So for tools and function calling, that's why I like to represent as MacGyver, who always has a tool that he can call in order to get his work done. And then lastly, this method that I'm going to talk about more today is using knowledge graph augmented context. So I have here the GOAT, the greatest of all time, Sherlock Holmes. I think that using knowledge graph augmented context is a very powerful way to introduce structured and relational knowledge into your agent's context. So Sherlock Holmes is what I think a perfect representation. So he's able to synthesize and track down and trace down important information and trace down the clues that are necessary in order to solve a particular problem. And this is exactly what context engineering allows you to do when you integrate knowledge graphs into your contextual AI stack. But how do they actually work? So to overcome AI's black box problem, right, we need knowledge to be transparent, right? So we see here, I have a human view of an apple, right? So we see that the human view of an apple is in the center. And then I have to the side, a vectorized view of an apple. And this includes a series of different numbers, right? These numbers are not really human readable or understandable. I don't know if you've memorized the vector representation of an apple. I definitely have not. But it's very opaque, right? The data is very opaque. It's not very human readable. You can't really understand it unless you are a computer. So then I want to show you as well, on the left here, we have a knowledge graph view of an apple. So we have an apple, and the apple comes from a tree, and an apple has a very specific body. It has a very specific look. It's round. This particular apple is red, right? An apple is a fruit. We're not talking about the company. Knowledge graphs make what can be understood by humans and what can be understood by computers. It matches them, right? It creates a fusion of both. Something that's very understandable to humans and very understandable to computers as well. And most people right now, most people have their data structured in tables and rows, right? We're relational people. We're relational database people. So we have our data stored in tables and rows. Most of us learned on tables and rows as well when we're learning software engineering and database architecture. But what you find often is that you have to do a number of different complex joins when you are trying to figure out how things are related, right? So we see here, for example, in this example here, we have a whole bunch of network data, and we're trying to figure out how generators, how buses, transformers, and links are all connected. But it's kind of hard to do those connections. And of course, those arrows that you see here don't exist in a SQL table. You'll have to actually do your joins in order to see what those relationships are. However, if you structure that same exact data as a knowledge graph, then the relationships, the connections, and the groupings become much more clear, right? So we see the ways that different aspects of the previous slide, the previous data, is actually related to each other. We can see these bidirectional or unidirectional arrows that shows, okay, this is connected to this. This has a maintenance record for this, right? We can actually visually, as humans, see the connections. And that's one of the benefits of using knowledge graphs to structure out your data, right? So in other words, a graph cannot just answer, for example, like what is relevant to my query text, but it can also answer what else is relevant, right? What else is connected to this topic that's necessary for me to include, right? So when this means that your agent's context can include things like A is related to B, which is then related to X, right? There's this multi-hop situation that you're able to do with knowledge graphs in ways that's more complex if you have to do them with regular relational data or data structures. And from an architectural standpoint, having a knowledge layer in your AI stack allows you to, number one, hold structure and meaning, and then number two, create a uniform memory layer and retrieval layer for your agents. And then number three, it also allows you to link and unify data sources and objects, right? So holding that structure and context, and then linking and unifying your data sources. And also number four, like all while bridging that human and that machine understanding. So it's a really helpful tool. It's a really helpful tool for building out your AI agents. And then at the bottom as well of that knowledge layer, you've got those existing data platforms. So either your Snowflake, your Databricks, even your normal relational systems. And on top of that, if you include a knowledge layer, even on top of that, it doesn't have to replace your original systems. It can just go on top of your normal systems. On top of that, you have your knowledge layer, which is then going to connect the structured and unstructured data in a consistent and semantically rich way. So from there, your Gen AI applications that are in the LLM orchestration layers, such as like LangChain or semantic kernel or different agentic frameworks, right? They can plug in and they can access all of that data contextually. And this is where the knowledge layer fits, right? It's how you retrieve grounded contextual information from the graph that I had just shown. And the benefit for agents is that by adding that knowledge layer in the graph, into the pipeline when paired specifically with MCP or Model Context Protocol with an MCP architecture, then the schema of a knowledge graph now provides so much context that when you break down a user question or prompt, that you start to see very clear and very logical flows of information, right? Or data, right? And that allows your agent's response back to be traceable, governable, auditable, and clear to you. So if we take this example question, for example, what asset managers are vulnerable to a lithium shortage? Okay, so when you're using only vector-based RAG or retrieval augmented generation, it's going to give you some general answers, right? Because a vector-based RAG uses spatial awareness, right? So area nearest neighbor, for example, different spatial or spatial information to try and pinpoint a particular answer. While graph-based RAG, in this instance, gave us a concrete list of the asset managers who would actually be impacted by a lithium shortage. And graph-based RAG output was able to specifically traverse the nodes, right? We had those circles and lines. It was able to traverse the nodes and edges and to then connect the dots. It understands which companies are actually using lithium. It identifies which asset managers actually hold positions in those specific companies. And then it reasons across the graph to produce a traceable and accurate risk profile for each company. So we can see here, right, based on the context provided, the asset managers that may be vulnerable to a lithium shortage are list. Exact list. That's what we want, right? We want that information, not generalizations. We want concrete information. That's correct. That's vital. And then we have a medical use case here as well. So in a medical use case, we can look at the following query as well, the natural language query. What was the care plan that was associated with Andrea Jenkins's emphysema? So let's look at these specific examples. So here we have a patient who has emphysema, and we're trying to retrieve a care plan in a medical sense. A direct call to an LLM is going to give us vague, generic text, right? The care plan associated with Andrea Jenkins, their user ID here, their emphysema, will likely include XYZ. But then a vector-based pipeline, which is better than just a direct call from an LLM, is going to give some more grounded info, right? But it's also incomplete, right? It's going to tell us, maybe some respiratory history, specifically some deep breathing and coughing exercises. Good luck. But a graph-based system is going to combine vector retrieval and structured connections that you get from the graph, which will then surface the precise treatments like smoking cessation counseling, rehab exercises, and the specific medication regimens that are necessary. And the graph makes makes the logic explicit, right? Which condition, right? Which care plan as well, and then what treatments. So once the agents have the necessary context in the structure of a knowledge graph, we can do so much, but don't take my word for it, right? Prove it. So there's actually lots of different massive companies who are making the shift in agentic development by implementing knowledge graphs as a core pillar to their AI architecture. So for example, LinkedIn, there's a seminal white paper by a staff software engineer at LinkedIn, Zhentao Zhu, and their entire team titled Retrieval Augmented Generation, with knowledge graphs for customer service question answering. And this paper specifically tested GraphRag to see if it actually benefited the customer service question answering process. And what they found was that by including knowledge graphs in their RAG pipeline, they saw a decrease in per issue resolution time of 28.6%. That's a 30% decrease in the amount of time that it takes to solve a customer problem, right? That's a significant improvement over the normal system for vital customer support. Which is why, for example, and that's just one example, but that's one example of why Satya Nadella themselves had called out access to an enterprise knowledge graph as being critical for enterprise AI applications at the Microsoft Build 2025 keynote, right? The entire keynote, Satya Nadella is talking about knowledge graphs as vital for AI applications. That's right. We've learned that building RAG apps that need a more sophisticated retrieval system, it's not good enough to just do vector search and some embeddings. The entire enterprise needs a knowledge graph. And that's also why Swami has also called out the importance of graphs in AI at reInvent. And this was the 2024 keynote, right? So obviously, knowledge graphs are a vital part of the AI stack, and it's a vital part of building out agents that allows them to work cohesively together and stop acting like a swarm. And those aren't all, right? All of these different companies are using graphs for context engineering with AI agents, right? We have Walmart, Uber, Adobe, AbbVie, Discover, right? Lots of different companies are now adopting. They're seeing the benefit of adding knowledge graphs into their agentic and context engineering systems. And they're saying, actually, there's something really big here, so let's invest. But I don't want you to just think that knowledge graphs are the only solution for your problem. I want you to consider all of the various techniques that we talked about today. Memory management, right? Ordering your context, putting the most important things first, right? All of these different techniques, I want you to improve the ways that you are engaging with context so that you can build better AI agents in the long term. So now, with all that we've learned, we can go from this, this chaos that we have here, where all the different AI agents are just doing whatever they can and, maybe they're finding the answer, but maybe they're not. We go from that to this. Oh yeah, okay. Organization, okay? He knows what he is doing. He knows what's going on. So this is easily coordinating your AI agents to then successfully gather data and gather knowledge for complex user queries, making your AI applications smarter and more efficient. Okay, so where do I learn more? So there are so many different places where you can go to learn more. One of them includes our Graph Academy, which is graphacademy.com, where you can learn how to build AI agents with Java specifically, and where you can learn about how to use knowledge graphs in order to make your AI agents smarter and more effective. But you can also go to nyah4j.com/developer, and that is going to have Java-specific techniques on how you can engage with knowledge graphs and Java. We have blog posts, we have videos, actually some done by my colleague who's going to speak today, Jennifer Reif, who is a Java expert, some that are actually done by her to teach you how to use knowledge graphs and Java all with your AI agents to make them smarter and more effective. And then lastly, I want to point you all to this incredible conference, which is actually happening on April 15th, so you don't have a lot of time, but this is a completely virtual online conference that's free, all right? That's free. That's happening on Leonard Euler's birthday, April 15th, and this is called Nodes AI, which is Nyah4J's online developer conference. It often pulls in about 15,000 attendees. Anyone who's interested in learning more should definitely attend that conference. And here's a QR code in order to register. So thank you all so much for joining me today. If you'd like to learn more about the things that I've talked about today, please feel free to find me on LinkedIn and let's chat. So happy to answer any questions, and I hope to see you at the next one. Take care.